let's start with our notes on concentration. And let's start off simple. Molarity is the unit of concentration that is far and away most commonly used within chemistry. Moles of solute per liter of solution. Most common way that you're going to see this is either with finding the concentration of a solution, or you could be doing a little solution stoichiometry like we did in the first unit, where you have to have the molarity in the liters of a solution. You solve for the moles of one thing, you can convert to moles of a product, and go from there. I'm not really going to do a sample problem with molarity to begin with, because we should be very familiar with molarity. However, molarity isn't the only unit of concentration used. There are different units of concentration depending upon the application. So the next one, and again, I'm not the one who names these things, so I apologize if the name is very similar to molarity. Next one is molality. Molality is equal to the moles of solute, so the same as before, but the denominator is different. Kilograms of solvent. So there's two differences between molarity and molality, and both deal with the numerator. I'm sorry, the denominator. Ooh, numerator is the same, moles of solute. Remember, we're talking about a solution. We're talking about something dissolved in something else. Far and away, water is the solvent that's being used. But you could have nonpolar solvents just the same. But we're talking about a concentration of something. The active ingredient, if you will, is the solute. So that's why that stays the same in both of these units of concentration. Moles of solute is in the numerator. The denominator, though, for molarity is liters of solution. For molality, it's kilograms of solvent. Two differences then. One is liters versus kilograms. Liters is a unit of volume. Kilograms is a unit of mass. Second difference is in molarity, it's liters of solution, which means that's the volume of both the solvent and the solute combined. Molality, it's kilograms of solvent, just like the water itself. One of the things that will help you out if you are doing a molality calculation is to remember the density of water. 1 gram of water is 1 milliliter of water. Therefore, 1 kilogram of water is 1 liter. Molarity is far and away the most common unit of concentration. However, there are times when molality is preferred. One of the reasons why molality would be used instead of molarity is molality is independent of temperature. What can change when you increase or decrease temperature? The volume can. Typically, when you increase temperature, volume gets larger. When you decrease temperature, volume gets smaller. So in other words, if we are dealing with things at extremely high or extremely low temperatures, that would affect the molarity because the volume would change. Now you're dividing by a bigger or smaller value. On the other hand, mass, kilograms, is independent of temperature. Like I said before we started notes, the next class period is going to be dedicated to something called colligative properties, which are these things that can affect normal properties of matter. So a solution versus a pure substance. There used to be calculations with the colligative properties that always dealt with molality, which is why this is brought up today, right before colligative properties. Lucky for you guys, you no longer have to know those equations. However, it did a good job of identifying why you needed to know what the molality calculation was. Second reason why we use molality instead of molarity is when solute and solvent combine, the volume of the solution is different now. Recall, when you make a solution, you should always be adding solvent at the end to get to whatever volume you need to avoid this issue. So usually how people will make a solution is they'll add a little bit of solvent first, then they'll add the solute and try to get it to dissolve, and then they'll add the water up to the final volume marking. At least that's what hopefully my lab assistants do when they make solutions on a regular basis. Besides using clean glassware, which they don't always do. Exhibit A is the copper nitrate solution in the back corner over there, just precipitate floating around in it. The practice sheet you're going to do in a little bit will have you practicing this math. Again, if you're given a grams of solute, you can convert grams to moles pretty easily. Use your periodic table, do a mole conversion. And then it would give you an amount of solvent. If it gives you a volume of solvent like 1 liter, remember 1 liter is the same as 1 kilogram. If you are more comfortable with molarity, that's the main unit of concentration you're going to be using. However, I do want you to be aware of how to use these other units of concentration. And in particular, the lab that you're doing next week, Wednesday, is going to have you solve for all 3 units of concentration at some point. Percent by mass is actually what our last lab had these solutions labeled in. 8% NaCl, 2% NaCl, 0.5% NaCl. Percent by mass is commonly what you see at grocery stores. Everyday citizens don't know what moles are. So instead, you take the mass of the solute, divide by the mass of the solution. And you know that gives you a decimal value multiplied by 100 to express it as a percent. Again, the advantage of percent by mass is there's no need to convert to moles, which is why it's used for everyday public. 3% hydrogen peroxide solution, 70% rubbing alcohol solution, like regular alcohol, booze has a percent by volume of alcohol in it. I like bringing up this hydrogen peroxide example because the lab that we are doing next week, Wednesday, is finding the molarity of a 3% hydrogen peroxide solution. So we're going to bring you back to the good old days of titration, and we're going to be able to figure out what is the molarity of that solution. But the example I have up on the board here, 3% is what the brown bottle hydrogen peroxide is sold as. That means there's 3 grams of hydrogen peroxide and 97 grams of water, because massive solution would be adding the 2 parts. By the way, we don't have to convert from one unit of concentration to another. That's something that used to have to be done. Quite frankly, that was one of the hardest things that old AP Chem students had to do. But if we had the density of a solution, we could easily do that. Give you a second, we'll move on to the last slide. Okay, here we go. Mole fraction is one that we actually have covered already. Perhaps you don't remember it though. Mole fraction is given to you on the AP equation sheet as well. Typically a capital X, maybe X sub A. So N is the abbreviation for moles, so the moles of one part of it divided by the total moles. Partial pressure, when we dealt with gas laws, hard to really go off of the mass of the gases. Hard to use the volume of a gas since the volume can be manipulated. So we wanted to go off of how many different types of gases are there. Remember, gases all behave the same in an ideal situation. So remember, ideal behavior of a gases means they're not too slow, so the temperature isn't really low, and they're not squeezed together, the pressure isn't really high. They'll all behave independently of one another. So all we need to know is how many moles of whatever gas we're referring to divided by the total number of moles, which gives mole fraction. So partial pressure was used for that. Vapor pressure is going to be one of the colligative properties that we bring up. But again, basically vapor pressure, when you go from a liquid to a gas, when that gas occurs, how much pressure is that gas supplying? So the colligative properties, next time we'll talk about something called vapor pressure lowering. When you add a solute to water, the vapor pressure at any given temperature is less now because there's less particles actually in the air. By and large, molarity, again, is the main unit of concentration you need to be aware of to do most of your math with. However, I want you to be familiar with these other three types. So that's what the practice sheet is going to be here in a little bit. The lab is going to cover that as well next week. But that's all we have for notes. So what we would do for the rest of the class is work on that practice sheet for a little bit, which I'll leave my answer key out for. And then, like I said, you get done with that a little bit early. A couple of good options would be, one, you could work on the web assignment already if you want to, especially if we want to work on some old ones if needed. Two, start looking at the review guide, of which I will get the answer key up on Moodle by the end of the day today. All right? Go ahead.